Bitcoin was built to move value across the internet without banks. But the base layer was never designed for coffee-sized payments at global scale. Every transaction competes for space in a block. When demand spikes, fees rise and confirmation times stretch. For a worldwide payment network, that's a bottleneck, not a bug in the idea, but a constraint in the architecture. Watch the mempool fill during a busy week. Thousands of transactions queue globally, each bidding for inclusion. Miners prioritize higher fees. A $5 payment might cost more to confirm than the payment itself. That economics works for large settlements and cold storage, but not for streaming micropayments, machine billing, or paying an API 20 times per minute. Lightning Network sits on top of Bitcoin like a fast lane. Instead of writing every payment to the blockchain, participants open payment channels, shared balances locked in a smart contract on-chain. Once open, thousands of payments can flow between those two parties instantly, with fees measured in fractions of a cent. The blockchain only sees the channel open and the channel close. Think of the base layer as a notary. It records the rules and settles disputes. Lightning is the conversation happening in real time between millions of participants who already trust the notary's math. That separation is what makes global micropayments possible. Settlement stays scarce and secure. Activity moves where speed matters. Opening a channel is a deliberate handshake. Alice and Bob each commit Bitcoin to a two-party contract. The contract encodes how funds can move, how either side can exit safely, and what happens if someone tries to cheat. When the channel opens, a transaction hits the base layer, one on-chain event that unlocks unlimited off-chain activity. Inside the channel, balance updates are exchanged as signed messages. Alice pays Bob by signing a new state, more sats on Bob's side, fewer on Alice's. Neither party publishes every update to the chain, they only need the blockchain if cooperation breaks down. Energy flows between the two nodes like water through a pipe that's already been installed. Closing works the same way in reverse. The latest agreed balance is broadcast on-chain. Both parties get their fair share. If someone tries to broadcast an old state to steal funds, the honest party has a time window to punish the cheat. The incentives align so honesty is the cheapest strategy. Now scale that picture to the whole planet. Alice doesn't need a channel with every merchant she might pay. She needs a path through the network, a route across nodes that already have liquidity between them. Lightning is a mesh of channels, not a hub-and-spoke card network. Payments hop from node to node until they reach the destination. Routing is dynamic. Software evaluates fees, channel capacity, and latency, then picks a path in milliseconds. Watch a payment packet leave a wallet in Berlin, traverse nodes in Amsterdam and London, and settle with a server in Virginia, all before you finish reading this sentence. The map of possible routes changes every second as channels open, close, and rebalance. When a hop fails, because a channel ran dry or a node went offline, the wallet doesn't ask you to try again manually. It selects another path and retries. That redundancy is why Lightning feels instant even though no single company owns the network. Failed routes are discarded in memory, successful ones become the new default for the next payment. Good routing is an engineering problem. Nodes advertise capacity through gossip messages. Wallets run pathfinding algorithms that balance cost against reliability. When a route fails, the payment tries another path automatically. The network behaves less like a single company and more like the internet itself, decentralized, redundant, adaptive. Liquidity management is the hidden work behind smooth routing. A node that forwards payments for others must keep enough outbound capacity on the right channels. Operators use circular rebalances, liquidity adds, and automated tools to move sats where demand is highest. Think of it as load balancing for money, invisible when tuned well, painful when neglected. Running a Lightning node means running infrastructure. Data centers and home servers host the software that gossip channel states, forward payments, and earn routing fees. Server racks glow with active channels, clusters of nodes connected by liquidity edges, pulsing as payments move through the graph. This is payment infrastructure in the same sense as fiber routes and DNS servers, invisible when it works, critical when it doesn't. Operators monitor uptime, disk, memory, and channel balance. Too little outbound liquidity and you can't forward payments. Too much idle capital and your Bitcoin isn't working. The best node runners treat liquidity like bandwidth, something to provision, measure, and optimize continuously. Privacy enters through onion routing, the same layered idea that protects traffic on the internet. A payment is wrapped in encryption layers, like nested envelopes. Each routing node peels one layer, learns only its immediate neighbor, and forwards the rest. No single hop sees the full path from sender to receiver. Information dissolves as it travels, leaving only the minimum each participant needs to do their job. That design matters at scale. A global mesh where every intermediary saw every sender and receiver would be a surveillance map. Onion routing keeps Lightning useful for ordinary commerce without turning node operators into involuntary data brokers. Underneath every hop is an HTLC, a hash time-locked contract. The sender locks funds with a cryptographic hash. Pay this invoice only if you can reveal the pre-image that matches the hash. The lock expires if the secret never arrives. Keys, hashes, and timeouts chain together so every node can enforce payment atomically, either the whole route succeeds or nothing moves. That's how trust scales without custodians. Compare HTLCs to handing someone a sealed box. The box opens only with the right key. Each intermediary forwards a box they can't fully open until the next hop completes. Cryptographic proof replaces phone calls to customer support. Timeouts ensure no one can hold funds hostage indefinitely. Where is this heading? Machine commerce. AI agents calling APIs, autonomous systems provisioning cloud capacity, infrastructure services billing per request, software that spends money without a human clicking approve. Lightning speed and programmability make it a natural rail for machine-to-machine settlement. Not subscriptions and invoices designed for dashboards, but payments embedded in protocols the way HTTP embeds status codes. Imagine an agent that reads a weather API, pays a few satoshis per call, and moves on. No API key rotation. No monthly minimum. No human in the loop at 3 in the morning. The payment rail becomes part of the stack, as normal as TLS or DNS. The base layer secures the rules. Lightning carries the flow. Onion routing protects the path. HTLCs enforce the promise. Nodes provide the mesh. Together they turn Bitcoin from a settlement layer into a living payment network, one that can keep up with software moving at machine speed. Master the mechanics, and you see why builders treat Lightning as infrastructure, not a feature. The network is already routing real value across continents. Channels are opening in every time zone. Liquidity is finding its paths. The next decade is about who plugs into it, wallets, APIs, agents, and services that speak SATs as fluently as they speak JSON.